In the majestic Andes Mountains of South America, engineers split sheer cliff to mass the road today so stream and in the shoals mistakes I price thy straight inner V hundreds of meters deep and through milmi lau calculations the antique shoe Julien Blouting and in Sheens Wen hundreds of ponds operating while playing to seep Maura Loca. Engineers have managed to create winding roads that trace the mountainsides like steel threads, reconnoting regions that were glazed centuries. Are you curious how engineers can force a road to clean to near way? Join Mandarin Tech I thought comes next. An Andes booming road advantages to transportation charge. It is a direct confrontation with some of the harshest terrain on the planet. Many highways in Peru, Chile, and Bolivia are constructed at elevations of 3,000 to 4,500 meters. Or thin air can reduce labor efficiency by 10 meters per year. And weather conditions can shift from sunlight over until TR. If these projects weren't citrus in the toll cost and spent on the roast tourists of, but on rock excavation, slope stabilization, in landslide prevention. In response, mountain roads in the Andes are usually built in two main stages. Our first stage faulting outer cliff face where engineers cut the road directly in the mountain, say by the slope anchors and detain RAR, and protect the roadway from rock high. When the terrain becomes too steep or unstable, constructions in the second stage, downhill to the mountain, allowing the road to bypass the most dangerous sections while reducing exposure to landslides in extreme weather. And now we will take a closer look at each stage of building a road along a cliff, starting from the moment the mountainside is still completely untouched. The first step in the process is to precisely determine the road center line and mark the construction boundaries directly on the rock face. Based on this layout, drill holes are arranged according to pre-calculated plans, and explosives are carefully loaded and thrown to break the rocky endings, ensuring that the overall stability of the Maui not comprise a free play. Once the rock is lean, excavators move in to pick up and remove the fragmented soil and stone, gradually clearing the construction surface. The material is then loaded directly onto heavy-duty trucks positioned along the edge of the road, ready for transport at the site. Trucks operate easily along temporary access roads, only debris designated to both raised planned vans, and free sections where the trail aisles bulldozers may push material directly down into the river or steep slopes below, shortening the time required for cypering. The next, bulldozers take on the role of shaping the road, pushing the weight excess material, and gradually carving the mountainside into the initial roadbed form. The blade is constantly adjusted to achieve the required slope and elevation, creating a rough but stable surface for further operations. This cycle of drilling, blasting, excavating, bulldozing, and grading is repeated section by section until a continuous roadway gradually takes shape, firmly anchored to the steep and dangerous cliff face. Once the ground surface has been leveled and stabilized, grade aggregate are trussed stone delivered by trucks and dumped as ships along the route line. Wheelers move into stoop re-street through weary, wearing it for the next stationly. After that, motor graders run along the route, spreading the material into uniform windrows and adjusting the elevation precisely according to the longitudinal and cross-sectional design profile. When the road shape meets the required specification, water trucks spray the entire surface to pull dust and create huge moisture reaction. Laboratory roars Acelia roars and begin compacting each layer, moving in multiple overlying passes at the third in curved sections or areas close to the cliff face. Radars continue fine-tune the roads and cross-slope to pub drain. Next, wars move on the route, and Olay has quieting each layer betu, preferring sable roadbed, or herbs layer is shucken. In narrow sections close to the raw face, or areas where roads fly safe, workers use phenophrine confiter to densify each layer of material, ensuring uniform compaction vang loklasema roadbed. After that, workers trim aus with safety anchors and carefully blind sea cliff face doth thus the rock first thoroughly. There eat ma drill to born to uneaf fashi. Regi off pershui rapai, a flarer unteri of low. Alpwa material poi by poi, uti heel chech on the fry wall cohesion to prevent sudden rockfalls or slow failure. Throughout the operation, all workers wear full personal protective equipment, including helmets, safety harnesses, masks, and gloves, to minimize risks while working in extremely hazardous terrain. Afterward, the entire cliff face is covered with a protective steel mesh, which absecil least rocks phagmus and reduces the risk of rockfalls onto the roadway below. Next comes the asphalt dish. Before laying the main asphalt layer, workers spray a thin coat of liquid asphalt onto the roadbed to create proper bonding between the structural layers. This asphalt coat is then heated using gas burners, allowing the solvent to evaporate and activating the asphalt bonding properties. During the asphalt language, the paper moves slowly along the road, continuously receiving hot asphalt mixed from dump trucks feeding directly into the front hopper. Behind the machine, the heat is screed teach the asphalt in a walkable state, spreading it into a smooth, continuous surface. Workers stand both sides the paver, closely monitoring the edges, a shovel, and reach uneven section to roadure. Into widening the paving indicated the asphalt were made a buoy tour, accrediting into coup within South Corthay with precise eye. Some work as solid drift behind the paver, street noise, gams, or girth cushion. The machine cannot maintain full control. The pace of both the paver, the supply chain, after me say to wood intrusion, a layer. Are the machine they see? He'll strip a black freculite asphalt, readily tation, marking Mobile stained and plain mot row. At the asphalt land ben lane, Workal you high prunchers prail, leaves roll. Erenu me lee stone or a zeston tree. Was spray nozzle remote evenly to ensure the roadway clear and that the asphalt's bonding and surface quality cannot figure. Once the asphalt sections continued, the road surface gradually cools a solid and continuous layer, quality revealing curves that closely fall monsai. For in bud, the winding road resembles a black ribbon straight across the glue face, marking the completion of an engineering work pulled and striage trade. In areas where the cliff face is almost vertical and there is no longer enough space to cut or widen the ground, the road might be suspended on the mountainside, using system reinforced concrete columns and prefabricated modular sections. Instead, excavating deeper into my Edlier's fifth vertical layer brought, using a face pillow as load-bearing days. First, large concrete columns are what hike onto the bedrock, acting as a primary structural stone at support the higher roadway. Due to the extreme terrain, most details can't be layered by conveyor wheel, and that may a plate crane, where trend pre-quimming or load for a bride there's at design zanes. What the crying pre every white ray, the robate modular door fish by thicken, much like handily dried leg by Maui. Each module is prefabricated to standard dimensions and includes steel girders, concrete slabs, and connection points, significantly reducing on-site construction time. Workers operating on height as always be secured with safety harnesses and work in close coordination. The crane operates to perfectly large component. As the modules are locked onto the comms, the tractor gradually forms a continuous road raid as the contours of the mound. Finally, the road surface is finished and safety barriers and drainage systems are installed to ensure long-term safety and durability. Interprouge not only allows roads to cross cliffs that would otherwise be impossible to build on, but also significantly reduce the overall issue quad. It represents a combination of modern surface engineering and an adaptive bear-with-the-drain IC, enabling transportation and infrastructure and just sustainably in hearty end terms. And as mentioned at the beginning, when neither carving the road into the cliff face nor building it on supporting columns is feasible, the next solution is to route the road directly through the mount by constructing a tunnel system. The project is given its first breath, the ventilation system. At depths of hundreds of meters, where pressure, dust, and heat can make the air toxic within minutes, engineers must create an artificial network to sustain life underfell. From the construction center, vertical shafts are drilled up to the surface, each about 4 to 6 meters wide, up to 200 meters high, bring in fresh air while expelling exhaust gas. Inside, sensors constantly monitor oxygen level, temperature, and toxic gases. Warding powerful jet fans to cool air through steam. These ventilation shafts are built using the raised boring technique, where the drill head is operated from inside the tunnel and pushed upward toward the surface with near-perfect precision. Once completed, the entire network becomes the lungs of the project, allowing hundreds of workers to labor for hours beneath the mountain, while still breathing the air of life. Outside, the construction site is shrouded in a haze of dust, while deep inside the mountain, a colossal machine is slowly being assembled, the tunnel boring machine, a true symbol of the modern infrastructure era. Positioning this giant for its first operation is a highly complex process that demands absolute precision and seamless coordination among hundreds of engineers. The entire system is delivered to the site through hundreds of specialized transport vehicles, each carrying modules weighing from dozens to hundreds of tons. Of the supporting frame and crew cabin to the hydraulic systems and the cutter head, heavy capoon, weighing over 1,500 tons and nearly 15 meters in diameter. A jury cold wind and brutally wing fused with steel and sprayed concrete to make rooms these must have combuids. In the confined space illuminated by hundreds of industrial lamps, the modules are connected and limed using laser sensors. The tolerance margin is no more than 5 millimeters. Powerful hydraulic jacks lift the cutter head and pin, linking step by step with the buy and hail station, according to preserved fields. Once fully assembled, the entire tunnel boring machine stretches nearly 100 meters long, the equivalent 30-story building laid outside, with thousands of mechanical parts perfectly fit together, forming a unified steel giant ready to pierce through the solid heart of the mountain. From the central control cabin, the electrical, hydraulic, and pneumatic features come alive. In an instant, the mountain trembles slightly. The tunnel boring machine begins to move. Nearly 100 meters long and weighing 3,000 tons, the machine ventures slowly at trolley. The algebra of mechanical hydraulics work hand in perfect harmony. At this stage, the cutter head is already buried deep in the rock, while the reeve section is still being fumbled a large timber, process requiring precise coordination between power, water, air, and compare systems that must run without interruption. At the front, 4 massive hydraulic cylinders rest the cutter head against the rock up to 500 tons of force. 23 alloy discs spin immense torque, crushing layers of rock as hard as steel. Each drilling cycle advances about 1.2 meters, taking roughly 30 minutes and repeating more than 50 times per shift. The crushed rock is collected and carried out by an automated conveyor, while high-pressure water jets constantly cool and clean the cutter head, reducing friction. Once a cycle ends, the gripper shield pushes forward, hydraulic clamps lock onto the tunnel walls, and the next cycle begins. This rhythm, press, release, advance, drill, repeats endlessly, day and night, until the tunnel is complete. A monumental project like Europe's Santa Lucia Tunnel, with a TBM diameter of merely 16 meters, arcs within 57 km Gotthard base tunnel, and shins operate 23 hours a day and unnighted per league. And today, China leads this underground frontier, with over 1,000 TBMs simultaneously carving railways, subways, and hydroelectric tunnels, a true symbol of its determination to conquer the depths with technology. Which nation's tunneling innovation impresses you the most? Deep inside the mountain, the drilling has stopped, but the work is far from over. Engineers, now carrying measuring instruments instead of drills, quietly enter the tunnel, where every meter of the country is put string. Pressure sensors and ground-penetrating radars scan the wall, detecting cracks thinner than a hair. High-frequency zone and 8K auto cameras inspect every bolt and seal to ensure flawless safety. In a control room, hundreds of real-time indicators track the tunnel's lungs, jet fans, soak sensors, drainage pumps, and a 10-megawatt backup processor. All tested in a strict AFP 502 and EN 505I45 air. Every reading brain so when non-lied until perfect is reached. Only then is the tunnel cleared ready, the true sun will passieren and hunes lias be there. So, you've just joined us in exploring the entire process of building roads on cliffs, from clinging to the rock face and erecting concrete pillars to sections that requires traversing the heart of the mountain. The information in this video has been come out in full RSOT. If you have any further questions, please feel free to leave a comment below. And now goodbye, see you the next years.